In Chapter 6, we start looking more closely at quadrilaterals, which are our four-sided polygons. Then specifically in Section 6.1, we classify those quadrilaterals, and then in later sections, we begin learning and talking about the different specific properties for each type. So here are just some definitions for you. All of these are special types of quadrilaterals. So a parallelogram is a quadrilateral that has both pairs of opposite sides being parallel. A rhombus is a type of parallelogram, but it's a more specific type of parallelogram because now it has four congruent sides. A rectangle is another type of special parallelogram, this time with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So some people know already that squares are really parallelograms, rhombuses, and rectangles, all in one specific shape. A kite is a quadrilateral that has two pairs of adjacent sides congruent. Adjacent, the term of adjacent means next to, so you have the idea of opposite, meaning they're not touching each other, or adjacent, which means they are intersecting, they are touching, they are next to each other. We have trapezoid, which is a quadrilateral that has at least one pair of parallel sides. Now, this definition is a little bit different than what you may have heard in the past. This is called the inclusive definition. The fact that it has at least one pair of parallel sides is a little different than what most students have heard in the past, which is that a trapezoid has only one pair of parallel sides. We'll talk about the difference in a little bit. And then an isosceles trapezoid is again a trapezoid that has that have congruent legs, and then base angles have the same measure. The legs in a trapezoid are the two non-parallel sides when you're looking at just a trapezoid, not any more specific. So now what I'd like you to do, draw and label a picture for each of these. If I go back here, draw and label a picture for what each of these would look like. Make sure you add the markings for each of the shapes so that you would be able to tell specifically which one it would be classified as. All right, now I'm going to actually skip ahead a little bit. I'm going to jump to the bottom of our note sheet where we see this diagram that shows how quadrilaterals are classified using this inclusive definition of a trapezoid. So the whole group is called the quadrilaterals. Now, from a quadrilateral, you really have two different ways you can go. You can be a kite, where you have adjacent sides congruent, or you can be a trapezoid, where you start seeing at least one pair of parallel sides. So now, from a trapezoid, at least one pair of parallel sides mean you could either have a parallelogram. So technically, when we use the inclusive definition of a trapezoid, a parallelogram is a type of trapezoid. That's very different for a lot of students. Or if you don't go the trapezoid route, the parallelogram route, you could have an isosceles trapezoid. So now you can see from each of these, you would continue to break down, and the most specific type of quadrilateral that we have is the square at the bottom of this diagram. So now, judging by appearance, we're supposed to classify this quadrilateral WXYZ in as many ways as possible, meaning use all of the terms that were just defined, use the diagram at the bottom of your note sheet, maybe start with the least specific and work your way to the most specific name. What names would be able to be used to classify this particular shape? So this shape is a quadrilateral. It's a polygon with four sides. It is a trapezoid because there appears to be at least one pair of sides that are parallel. It's a parallelogram because now it looks like we have both pairs of opposite sides parallel. And it also appears to be a rhombus because it looks like a parallelogram, but we're shown that all four sides are congruent. So now that we've identified the four different ways it could be classified, again, just based on appearance, I realize we don't have any information to specifically say we have parallel sides. But again, we're told to just go off of appearance, so we're able to do that. Now, which of these names up above gives us the most information about this quadrilateral WXYZ? The most specific name would be the rhombus. It tells us we have a parallelogram, meaning we have both pairs of opposite sides that are parallel, which we also know is automatically a quadrilateral. And again, parallelogram with our new inclusive definition of a trapezoid. Okay, once we know we have a parallelogram, we have to also know that it's a trapezoid. And the biggest key here, why it's a rhombus, is that it tells us we have four congruent sides. So now a little coordinate geometry from this section for us. Our job is to, if we're given 4 points, 4 vertices of a quadrilateral, is to determine the most precise name for that quadrilateral. So much like we did with number 3, rhombus was the most precise name. So here we're trying to do the same thing. So when I do problems like this, the first thing I always suggest is that we look at slopes. Slopes are easy to calculate, or even if you have a graph, you could read the graph and figure out what the slope is. So these tell me a lot of information, doing some pretty simple figuring. So if I go through and I find the slopes of all 4 of these sides, which I've already done here for us, I would find that the slope of segment LM is 1/2, the slope of segment MN is -1/2, the slope of segment NP is +1/2, and the slope of segment PL is -1/2. So now I have to think, what does this tell me if I look at these 4 slopes? I have to be able to tell that I have opposite sides that are parallel and adjacent sides that are not perpendicular. So if we look at segment LM and segment NP, they have the same slope. In my diagram, they're opposite from each other. So if they're opposite from each other and they have the same slope, they have to be parallel lines. And then if I look at, for example, segment LM and segment MN, the slopes are just opposites. They are not opposite reciprocals. Opposite reciprocals tell me I have perpendicular lines. So in this case, these are not perpendicular. So what this has done is this has narrowed down all of our possibilities from just a quadrilateral or a kite or a rectangle. Of all of those shapes that we have defined on the front of our notes, if we have opposite sides that are parallel, there are 2 pairs of them, that narrows down all of the possibilities to this just being possibly a parallelogram or a rhombus. So we have to think about, well, what's the difference between the parallelogram and a rhombus now? That's the next thing that we have to somehow show so that we can decide which of those 2 is the more precise name. So the difference between a parallelogram and a rhombus is that a parallelogram, all 4 sides are not congruent, and in a rhombus, they are. So if you're trying to show that sides are congruent, you have to show that they have the same length. That means you need to use distance formula. So as of right now, I do want you to do all 4 side lengths. So here I have done those for us. If you need to refresh yourself with what the distance formula is, so you have that in your notes. You may look it up. So noticing the answers that I get from doing all 4 of these distance formulas, I need to be able to make the conclusion that all sides are congruent. So out of the 2 remaining possibilities, parallelogram or rhombus, which one of those has all sides being congruent? That would be the rhombus. This is why the answer, the most precise name for this quadrilateral, is a rhombus. I'd like you to try 6 on your own. Now I've given you a graph that does not have a grid behind it. I don't want you to take the time to measure out and create your own grid. The whole point of this is to just get you to make a sketch, meaning you don't have to do it on graph paper. It doesn't have to be perfect. It just gives you a rough idea of what the object looks like to kind of help you and maybe guide you in what pieces of information you're actually going to find. So please pause this video and work through this and see if you can determine the most precise name for quadrilateral ABC with the given vertices. So again, I've sketched my picture. I found the 4 slopes first. This time with my slopes, I have to notice not only do I have opposite sides that are parallel, but I also have to notice my slopes are opposite reciprocals. The slope of segment AB is 1/5. The slope of segment BC is -5. Those are opposite reciprocals, which tell me those lines are perpendicular, which means they're forming right angles. And then I also did the lengths of all of the sides of the quadrilateral. So the slopes would have told me that I have a rectangle possibly or a square. Now the fact that all 4 sides are the same length, this gives me the final answer of this being a square. The last couple of things we have is we are just using the definitions of our polygons, our quadrilaterals here, and to find the values of some variables in different shapes. So in number 7, we have a kite. So if you need to, look back at the definition of a kite and try to determine how you would figure out the values of x and y, and then go ahead and actually solve those. So since this is a kite, and a kite is a quadrilateral that has 2 pairs of adjacent sides congruent, we would need to take the lengths of JT and KT and set them equal. Issue there being, we'd have 2y plus 5 equals x plus 6. There's 2 different variables. I can't solve that one right away. So we have to look at segments JB and KB and set those equal. That's our second pair of adjacent sides that are congruent. And that only has x's in it, so we could solve that, and then we can use that answer to plug in and solve for y. So we see here we have x equals 9 and y equals 5 for your answers. In number 8, here you're told this is a rhombus. So if you need to, you go look back at the definition of a rhombus and solve for A and B. So here we have the work to find the values of A and B. But now notice again, the job here is to find the lengths of the sides of the rhombus, not just solving for the variables like it was in number 7. So make sure you're reading carefully. Here, since all 4 sides are congruent by the definition of a rhombus, all 4 of those side lengths would be 14.